This paper was presented at the JCT Traffic Signals Symposium 2023 in Nottingham, thanks to the support of AGD Systems, Inrix, Message Maker Displays, PTV Group, Simplify Systems, Smart Micro UK and TRL Software.
Some name checks first. Not only Peter and myself, but Andy Graham of White Willow and John Wade of Interoperate have contributed to the work in this project. It is funded by, I saw Darren earlier, thank you. It is funded by TTF, for which we are grateful. And I would acknowledge something that Suku just said a few moments ago. Shared data in the right format at the right time. Now, compared with what Suku just described, we are very, very fortunate because we have, although it doesn't sometimes feel like it, a very small part of the problem, looking at the static data that relates to signal controllers. So, it's not just technical, but given the audience, we'll try and keep it technical. We want to talk a little bit about processes and how we open the data up. And there's a paper in the proceedings, because John said we were incredibly boring, so we need to keep this tight and on time. And so please read that. Why? Well, effectively, we all know, we all work with, there are out there a huge number of signalised crossings, signalised junctions. But actually, if you're, and forgive me if North Yorkshire are here, if you're North Yorkshire or West Sussex, who I believe are here or whatever, you don't hold your data in the same way. You don't hold it in a way which allows it to be easily shared outside of your borders. So if anyone says nationally, how much of, what characteristics, et cetera, about our signalised asset base, at the moment, we're not sure the answers are easy to find. So this project is looking at identifying sites, given the characteristics, defining them geographically, and again, Suku talked about C-roads and MAP-M, I'll come on to that in a moment, and then trying to capture information on how those sites are actually being controlled. I think at that point, my notes say that I give Peter...
You're earlier than me. Excellent. No, I thought you kept going, Mark, but I'll keep with the why. No, you've blasted through, thank you. So, the scope. I'm going to give you a minute to sort of digest the diagram on the page. There is a lot in it. As Mark alluded to, we've got the C-roads part in the middle, we've got the government at the top, and we've got industry at the bottom. Now, the players listed there, that's not exhaustive, but they're the big ones we're familiar with. A key part of this is we are not dictating, we're not saying this is how it is. Everyone's view is valuable, we want feedback as this goes forward. And we're not aiming, as I say, to exclude anybody. The key bit we're talking about today is this vertical stack called DSIS in the middle. And we're going to iterate through those things and talk about what it looks like, the why of it. Because in the presentations we've heard about data structure, we have to think about, well, how's it going to be got? And if you come off the ferry in Dover and you want to drive to John O'Groats, you want to talk to the signals. But how do we identify them? Of the authorities that are here, I'm pretty sure most of the numbering schemas will vary wildly. There will be conflicting numbering schemas, and we have to work around that to create something that will work. Okay, so first one, intersection summary document, top of the stack, and it holds. The idea is this will be a JSON file holding the data of all the sites within a geographic boundary. It's an ambiguous wording in terms of how I can't actually see a scroll. I'll have to look this way, but this is what it'll look like. And this is a sample for a York site, but the document itself will hold every site within York. So if you are a consumer, and in fact, I suppose one thing I have jumped over is on this particular diagram, what you can see to the right are the use cases. This isn't just connected vehicles. There is asset management cases for this. We know how many things we have of a type. The term digital twin's being used, but this helps us get towards that. We've talked about the earlier presentation, the fantastic one was about the journey. If anyone was to try and do a walking journey, say Google Maps, for example, not all of the network is there, but if we could get more data of these crossings have tactiles, there are audibles, data that's known, but sometimes you wouldn't know it's there till you got there kind of thing, we can improve the journey for people. So, this file, if I sort of go through it, it's a GeoJSON one, so it's a standard structure, it's a structure that people can understand. And the key thing, Road Authority ID. That's the first one, because we're going to have to identify these sites. And we're using a European standard, and so we have at our disposal for identifying the sites, we've got two 16-bit integers to play with. I can ask, but I will tell you, a 16-bit integer is 65,535. So if you put them together as two numbers, it sounds like a lot, but it's not really, because the current change in the European spec means the first two digits of the first 16-bit integer becomes country code. That means we've got the space for 999 operators or areas within the country, which is what's led us towards a geographic space for that part. The second part is the local authority ID. Now, most of the local authority in the room will say, well, if you've done it underneath a country code and an area code, well, why can't I use my numbering? Well, if anyone's got letters or it doesn't fit, there has to be this a numeric number that you as an authority will have to own in order to be able to broadcast the details about your sites. But this big number will then propagate through the stack of every piece of data that we've talked about. That is the key reference that will be what will be broadcasted, as Suka alluded to say, this is this site. And as services that are aware and they get to it and they say, is there anything here? They get the reference and they can go away and pull the data and do things with that. We've also then got some additional properties. Now, address, sort of spatially stuff. We consider this at this time sort of an extensible area. But for small payload, if everyone had that, you could very easily answer those questions. How many junctions are there? How many have got crossing facilities and that kind of thing? The trick, though, is if you make it so big and it doesn't get populated, the value is lower. So we're trying to have this balance as to what should be in this. And then the coordinates, they are what it says on the tin. So, authority numbering. So, this is the key bit for those of the authorities in the room. And as I've said, we need to follow CEN TS 19091, the SAE standard J2735. I definitely needed the paper to write that one. I'll have that written down, I can tell you. So we need to use standards that exist and not invent a new one. Key thing is, though, it's not just about singles, it's about streams, it's points of conflict kind of thing. So as you can see here, although the numbering will change as because as we're picking up a new standard, it would probably be 50 and then it would be the authority identifier. The streams of the site then picked up. So what we're proposing to do is, rather than using the full width of the 65,000 part, we will slice off some test space at the bottom. There will be some space above, because let's be honest, the most disruptive thing potentially on the network are portable signals or temporaries. That's what it's important, if we can share that data as well so it can be picked up and used. So what we're doing is we're working in decades. So what you can see for the first site on the left, 10540, the second site is on the right, so it's jumped up by 10. That allows us to have the conflict zones effectively in that extra space, using the 1, 2, 3, 4. I can't imagine, I know there will be people saying, but we've got a site that's got 16 streams or what have you, then we would just, you roll over to the next decade and use that. The key thing here is the asset owners have to maintain this list of sites so it can be published. Now, I'm happily going to hand over back to Mark on the definition of the road layout part.
So Peter has taken the first slice of this file structure. What's the identity of the site? Where is it? Who is responsible? Well, geographically, where does it fall? What are its key characteristics? So now we move on to say, geographically, what does it look like? So this is straight out of the C-Roads MAPM specification, because why would you reinvent a wheel? Well, you wouldn't, would you? I'm just going to quickly crash through on this and the next slide the main characteristics of this file. This allows you to uniquely identify the approaches into a junction, numbered clockwise from the north, the lanes into a junction, ditto, and as you can see there, it identifies routes through the junction, permitted entries to permitted exits. So that's the ways you can actually, as a road user, move through it. The lanes geographically are identified by a series of nodes along their center lines, all referenced to an arbitrary but central reference point, the red dot called ref point, helpfully up there in the diagram. So The aim of the MapM format is to define the geography of the junction in the smallest amount of data. That's why this particular structure is used. There are other characteristics of lanes that can be allocated, and I'm sorry, I've rather lost track of what's up. No, that one, that's good. You can identify lanes for particular vehicle types, which means pavements and crossings can become pedestrians as, not vehicle types, road users, sorry. You can give them characteristics for use by time of day and so on. So you can ultimately, within a MapM file, specify how that physical space is used. And importantly, within the context of this digital controller interface standard, that file has the same intersection ID that the characteristics of the site have. And it also has references to what our colleagues in Europe call signal groups, and we tend to call phases. It identifies which signals are responsible for controlling which movements. So there's a nice little swept path from the left down to the bottom there. Obviously, there'll be a set of signals controlling that movement. So within the MapM file, which is the second of these three files, we have information about where the site is physically, how many lanes, how you get into it, how you get out of it, and how it is signalized. And now I get the privilege of handing this back to Peter to talk about how it is controlled.
Right. This is the meat of it, and I'm conscious the yellow light is on, but it's the meat for this audience. The control logic of a site. This is something that if it can be shared, you know, the use cases can draw down hugely from this. And there's two ways to look at it. Do you take it on what goes in on the left-hand side of the equation? We have to be careful using the term 2500 141s, because if you create one and pass it to a contractor who then generates an outcome, you will get the same functional result, but it may have occurred in 3 different ways. So what we've got here is a sample of what this file will look like in an effort when we've tried to standardize it. The key thing is, though, again, there's the link to the UID. This is the site. It's broken into logical blocks, and it will have to come from the configuration tools in order to generate that standard. And it needs the buy-in, and people need to see the use case and understand where the value comes from. So this, as I say, I mean, I'll wander over this way. You can see sort of the start of it is where it is, what is on this side, the history of it as it's been built, the bits, and a lot of these things, if you think of from this particular slide, so if you look at IC4, for example, these are fields that are on the first, it's what's captured about it. This goes on. As far as there's 4,000 lines in this file as it stands for what is a relatively small T-junction. We then get into phases, and what we're trying to do is create it in such a way that whoever configures your signals, there will be a standardized outcome. So people will be able to iterate over everything. So if you think, we've got the unique ID, we know where it is. We've got the map data, so we know how the lanes work. We've got the control logic. You could do some incredible things by being able to process all that data in one go, because you're not having to translate it. It'll all be in the same structure. But we do accept that normalizing is going to be hard. We're not going to get 100% alignment. And there will be areas where we're going to have to take a pragmatic decision based on, you know, if there's really bespoke stuff out there. The good thing is that, and we've got, you know, a controller maybe loaded with VA maxes, and you'll quite rightly say to me, but Peter, this site runs Mover, it runs UTC. That's not representative of what we'd be doing. But a Mover data set, and it is a structured, standardized file that can be run into modeling. There can be other ways, and it'll just simplify being able to do things with the data. We also know, because someone will say, special conditioning, there are some incredibly good configuration engineers out there. Ultimately, though, what we have to do with that is store it in the data with a warning of here be dragons. And then when people are using it to build stuff, it can be, well, you're going to have to look at that and understand this is what it's saying and what the impact will be. So I've jumped ahead, I'm one step ahead of myself. There's detection as well, and obviously one of the key themes that's come across over the 2 days so far is above ground detection and sort of the classification, the more data, and there is ongoing work within Topaz, I'm looking at Mark, don't want to get it wrong, to do with an enhanced detector specification that can then tie into this. So when you take the data and want to build a model, you know where the detectors are, you understand what they're capable of. But there's also the supplier improvements that have been made over 2500 as a Topaz 2500, because that is the what but not the how, and there's been different ways, so it is a challenge to get this into a standard format. Again though, I could bore you all day on this, so that is the digest version for me to hand back over to Mark.
Thank you, Peter. Red light's on. So we are midway through this, not midway, we are in the throes of this project, but JCT only comes around once a year, so we use this opportunity to tell you where we've got to. We are engaging with the signal companies. There has been some outreach via the UDG to this community on some of the numbering stuff. There will be more outreach. We are looking at guidance. We are looking at processes. And Suku talked about the national access point and keeping information on digital TROs. We're looking for a centrally accessible home so that when projects roll through and the site information is digitised and these files are made available, they will be stored in a way which makes them accessible. Because if you can't get to them, they're no use to man nor beast. And that is an incredibly quick gallop through all that. So to try and get us back on time, which I know John will appreciate, thank you for your attention. And if there are any questions...
Thank you, chaps. I think we have time for maybe two very quick questions. So I'm not sure who's closest. There's in the middle there, and we've got Alistair at the top.
Thank you, Robert Mansell Atkins. Where do you even start with signals on private land or out with authority control, airports, shopping centres, business parks, hospitals, etc.?
I'm sorry, I didn't get that.
Okay. Your question is, it's stuff that's out with local authority or National Highways, Transport, Scotland, GIFT. Again, the nature of what you say is private, and there's different flavours. It could be in a steelworks that's never used by anyone. It could be in a shopping centre that is used all the time, and members of the public don't appreciate that it is. So Suku made a point in terms of whether it can be forced down on people as a legislative measure. Whether that can be applied in a private context, to be uncertain. But certainly, it's a challenge. I wish I had a better answer for you, but you can't make them, as you say, they're private. They're not within our gift to dictate. But hopefully it can be a thing that's part of, if they're specifying, maintaining and running signals, which typically have to look like a UK highway one, then we have to gently encourage them, but also come at them from the supply chain end. You specified a Topaz 2500 controller. Here is the output file that you need to make available to your local authority. So try and bring them along with us.
Okay, thank you. And Alistair.
Hi there. Alistair Gollop, ITS Now. We've had a conversation about the configuration data associated with this. I think it's worth noting for everyone here that we will continue to support the ITS 1827 forms through the transition to a JSON-based electronic system. So if you're looking for configuration forms in which to enter the data originally for the signal companies, they're still available from itsnow.org. Thank you.
Can I?
Oh, please, Mark.
So Alistair there is talking about how you get data in for typically a new site. What we're saying is there are how many thousand sites, and we come back to the numbering originally, there's some 30,000 sites across the UK where the information already exists, and we want to be able to access that stuff. So what Alistair's saying is welcome, but that's the beginning of the sausage machine, so to speak, and we're picking up the sausages that have been made already and trying to standardise them, so that comes a bit later on.
Yeah. We need the tooling to normalise it, so the process for specification doesn't change.
Okay, thank you.
Can I name check the guys from Telent and from Dynix Swarco and from Unix, because they have been incredibly helpful thus far on the project. We are talking to the portable and temporary players as well. We will be engaging with all of you. Sorry, but we will.
We are going to have to move on. Thank you, guys. Thank you very much.